Hello everyone, my name is Raina DJWT, and this is my concepts video for Module 8. I'm going to walk through 3 concepts from my full stack admin project that really stretched me as a newer developer. When I was building this application, there were ideas that made me stop and think, how does this actually work? The 3 concepts are dual authentication with JWT in sessions, MongoDB aggregation pipelines, and atomic transactions. So without further ado, let's get started. So the first concept is the JWT dual session authentication. So when you log into most web applications, the app needs to remember who you are. But there's 2 different things that need remembering: API requests and page loads. And in this application, I needed to protect both of those. So I built a 2-layer system. Layer 1 is JWT tokens stored in session storage. Layer 2 is session cookies validated against MongoDB. So when you log in, the first thing that happens is you post credentials to the API auth login. The backend will validate that, and then it generates a JWT token and then sends it back. The front end stores the token in session storage, and then the front end immediately makes a second API call to API session to create a session. Then the backend generates a UUID, stores it in MongoDB, and sends it back as an HTTP only cookie. So now we have 2 tokens. We have JWT in session storage, and then we have a session UUID in browser cookies. So every API request includes this authorization bearer JWT token in the header. The backend validates the JWT signature. Every page navigation hits the protected route component, which calls the API session validate with a cookie. So the backend checks if that UUID exists in MongoDB and it hasn't expired. So I kept thinking that a cookie and session storage was the same thing. They're both tokens, they both authenticate you, they both expire, but they're completely separate. The JWT is what is called stateless, so the server doesn't store it anywhere. It just signs it with a secret key, sends it to you, and then you send it back. The server verifies the signature. If it's valid, you're in, no database lookup. The session is stateful, so the UUID is stored in MongoDB. Every validation hits the database. If I delete the session document, then the cookie becomes useless instantly. It took me days to understand the difference between these 2 and why you would need both of them. And the answer is defense in depth. So if someone steals your JWT from session storage, they can make API calls, but they can't navigate pages because they don't have the cookie. If someone somehow steals the cookie, they can navigate pages, but they can't make API calls without the JWT. And also, the logout is cleaner, so I delete the session from MongoDB and clear session storage. Both layers invalidate. The other thing that blew my mind was MongoDB's TTL index. So in my session model, we see this expires at index expires 0. So this expires 0 tells MongoDB to automatically delete any document where expires at is in the past. I set the expires at to 24 hours from creation, and MongoDB just deletes it for me. No cleanup script or manual deletion. The database just handles its own garbage collection. That was a new concept because I have always manipulated the database myself up until this point, and so giving it a command to run in the future was something totally new. It just taught me that databases can have behavior and not just be used to store data. So let's move on to concept number 2, which is the MongoDB aggregation pipelines. My reports page shows 2 charts: a bar chart of total sales by agent, and a line chart of daily sales for the last 14 days. If I had thousands of transaction documents, I could fetch all of them and calculate the totals in JavaScript, but that would be super slow and super wasteful. So instead, we built what's called an aggregation pipeline. So I think of them like a factory assembly line for data. Each stage transforms the data and passes it to the next stage. So our pipeline lives in this report.js, and the pipeline goes from lookup to project to sort. So first we start with the agent collection, not the transactions. This is important because I needed to include all agents, even the ones that had no transactions at all. Instead of a simple join, we use a pipeline inside of this lookup. It matches the transactions with the agent ID, and it builds an array of transactions per agent. Then we move to project, and this is where the data transforms. So we build the agent's full name using this first name and last name, then we calculate the total amount by summing all transaction amounts in that joined array. If an agent has no transactions, then the sum is just 0. And then we sort finally by agent name alphabetically. This 1 means ascending and a -1 would be descending. And this is just to make the chart more readable and organized. Originally, I started from the transaction collection and grouped by agent ID. It seemed like the logical thing to do, but it silently dropped the agents with 0 transactions. So the realization was if I want all agents, I have to start with the agents collection, and that shift fixed the chart completely. And right underneath it is the daily line chart, and this pipeline is a little bit more straightforward. So we go match and then group and then sort. So match filters transactions only for the last 14 days. The group by date using the date to string and the sum total per day. And then we sort by date ascending so the chart flows correctly. And MongoDB only returns days that actually have transactions. So if nothing happened on a certain day, that date was completely missing. And so my chart actually showed dates from like 4 weeks ago instead of 1 week ago, depending on the transaction date. But chart.js expects a continuous x-axis, so missing dates breaks that visual flow. So instead of solving this in MongoDB, I handled it in the backend JavaScript. So I generated a full 14 date range manually. So moving on to concept number 3, which is the atomic transactions with MongoDB sessions. We're looking at the transaction page now. Whenever we add a new transaction form, 2 things have to happen at once. Number 1 is we have to create a transaction document, and number 2 is that we have to increment the sales count by 1. So if the transaction saves but the agent update fails, then the data is inconsistent. The transaction exists but the agent's sales count is wrong. So let's jump over to the code and figure out what's actually happening here. So taking a look at transaction.js, this line right here, this constant DB session, this is how we are creating a transaction context. So nothing transactional is actually happening yet. This just prepares MongoDB for it. Then we wrap everything with this with transaction async. So instead of doing start transaction, commit transaction, abort transaction, MongoDB now automatically commits if everything succeeds and automatically aborts if anything throws an error. And then this line right here, this const agent await, we're pulling an agent from the database. This session DB session, ensures that this read is part of the transaction. It stays consistent with any pending writes. And then this if statement, if the agent doesn't exist, we throw an error immediately because this is inside of this with transaction. So the entire transaction is aborted automatically if the agent doesn't exist. And then this is just normalizing all of the name fields. This is because I had a little bit of inconsistency with the naming schema. Because this is a continuation of another project, I ran into the issue where the agents that I imported were different than the create agent form. So instead of having to kind of change 2 very big pieces of my project, I instead normalized just to be extra sure that no agents are dropped just because the naming case is different. And then we create the transaction. So we insert a new transaction record, and this is still happening inside of the transaction. We haven't committed this yet. Then we see this await agent update 1. This increments the agent sales by whatever the transaction amount is. So it's still inside of the same transaction. And at this point, we have a pending transaction record and a pending agent update. Neither of them have been committed yet. And when this finishes successfully, we see this await DB session end session. And then MongoDB commits the transaction and both operations are saved together. So the system now guarantees that if everything works properly, transaction is saved and agent sales are updated. And if anything fails, then nothing is saved. So what made this concept a little bit hard is I have never worked with database transactions before. The idea of, and I'm probably going to say this wrong, atomicity or atomicity, atomicness, that a group of operations is treated as a single unit was very abstract to me. So in regular code, if you do await transaction, create new transaction, and await agent find one and update, fails. The first write has already happened. You can't undo it. You have to write rollback logic manually. Sessions is what fixes this. So the database holds the writes in a pending state until everything is committed. If you abort, it's like it never happened and nothing actually gets saved. And the actual syntax of this felt foreign too. So you start a session, start a transaction on that session, pass session into every query, then commit or abort. If you forget to pass the session into a query, that query happens outside the transaction and then you lose the atomicity. I tried to figure this one out for hours because I forgot to pass session to agent find one and update. The transaction would create and the agent would update, but if I forced an error, only the transaction rolled back. The agent update had already been committed. Once I understood that the session object is what links everything together, it started to make more sense. So those are the three concepts that challenged me the most this week. The dual authentication, because it's two separate systems working together. Aggregation pipelines, because they require thinking in stages instead of queries. And atomic transactions, because they introduced a whole new layer of control over database rights. 8 weeks in, I didn't expect to be dealing with TCL indexes, lookup stages, and rollback logic, but that's what makes this project so valuable. I had to dig into the why and not just the how. And I've noticed that as I continue this program, I'm thinking less about the actual words that I'm typing in the code that I'm writing and more about picturing what am I trying to do here and expanding my perspective. So it's not just buttons on a screen. It's more of like seeing a picture of how does this all work together and where can I pinpoint the problem. So that's all I have for this video. Thank you for watching. Thank you for listening, and I will see you on the next one.